So this is a video lecture for the Climate Factors Lab. You each have a copy of this slide deck, and you will submit the entire slide deck once you answer the questions in Schoology when you're done. So what affects weather and climate? There are 6 main factors we're going to talk about today. Ocean currents, whether they're warm or cold, near a given city or location, the air masses that dominate, the latitude, which is those horizontal lines parallel to the equator on the Earth. Are you at a northern or southern latitude, a high latitude, or a low latitude near the equator? The elevation, how far up you are from the sea level. Something called the orographic effect, or the proximity to large bodies of water. So let's go through each of those in turn. First of all, ocean currents. And you can see that because of the currents that occur in the ocean, and that's largely due to density differences, due to temperature differences. So we have colder water at the north and south. We have warmer water at the equator. That drives a circulation pattern in our oceans. And you can see that some of those currents, so for example, here we have the Gulf Stream coming up the eastern coast of the US. That's a warm water current. So those cities are going to tend to be warmer than what we see, for example, on the opposite side of the Atlantic Ocean, where we have water coming from the northern areas that's cool. These currents are cold. The Canary Current, for example, by the Canary Islands. So those cities may be cooler, relatively speaking. This works the other way too, where this cold upwelling happens, this California current coming down the coast of California, that water is cold. Those beaches are cooler than the ones you'd find on the East Coast, say, for example, Florida. All right, and you can look, here is a satellite picture. You can see represented in colors that Gulf Stream coming up is warm water. And you can look at those right here. If you click on that link in your slide deck, and you can see, click over here, and you can look at ocean currents right there. And click back down to close it, but this will give you a sense of the ocean currents and their temperatures all around the globe. All right, so I'm going to close that out. I'm going to go back here. All right, so how do ocean currents affect climate? Warm currents tend to lead to a warm climate. Cold currents lead to a cold climate. All right, the next one, air masses. So we've learned about this in assignments. So we have the major air masses that dominate the contiguous U.S., lower 48 states, and they are designated by 2 letters. Maritime, those currents come from the sea. Continental come from the land, so they're either maritime or continental, each one. And then they're either polar, from the northern latitudes in our case, there's an equivalent one in the south, or tropical, more from the equator, where it's warmer. So air masses make a big difference in climate too. And if you see this, the origin and characteristics of air masses, a continental would be dry, and we see here, tropical from the equator would be hot. So a continental tropical air mass would be hot and dry, more like would create a desert climate. Maritime tropical, maritime from the sea, so a wet or moist air mass, tropical coming from warm, you would then have warm and wet or warm and moist air affecting the climate, and so on and so forth. All right, the third effect of climate, third factor that we consider is latitude. So of course, latitude, we have the equator across the big belt across the middle of the earth, that biggest part of the earth, and that is warm because it has the most direct sunlight. And the poles are of course colder. because that sunlight is less direct on those areas. Some people sometimes think it's, distance, that the poles are more distant from the sun, but that distance is so insignificant. It's really actually about the angle of the sun. So if we look at how does that angle of insolation, so that sunlight coming in and it hits the poles at a lower angle, whereas the sun hitting the equatorial areas is very direct overhead. And you can think about that like when you're outside and the sun is directly overhead in the summer, it is so much warmer than in the winter where it may be lower in the sky. It just does not heat the ground up, heat that atmosphere up as efficiently. So how does the angle of insolation affect climate? The latitudes that are north of the Tropic of Cancer have a lower angle of incoming sunlight. So those northern latitudes, or equivalent, the southern latitudes south of the Tropic of Capricorn have a lower angle of incoming sunlight. So they're cooler climates. Latitudes around the equator have a higher angle of incoming sunlight, more direct, 90 degrees above head, and those are warmer climates. So how does latitude affect climate? And here's a graph. If the temperature, the average temperature of that climate versus the latitude, remember 0 degrees here is the equator, so the temperature is hot. 90 degrees is the poles, either the North Pole or the South Pole, so the higher latitude you go, the lower the temperature. As latitude increases, the average annual temperature decreases. That's the relationship. All right, another climate factor we look at is elevation. So the temperature of the atmosphere drops 3 degrees Fahrenheit for every 1,000 feet in elevation rise. So that is quite a bit, actually. If you've ever noticed, if you're climbing a mountain or driving up a mountain, you can really feel the difference between what it feels like at the bottom of the mountain and what it feels like up at the top. So for example, if we're in a tropical forest, this happens in Hawaii where you're at sea level literally, and it might be 85 degrees or 90 degrees as it shows here, and you go up, and those mountains, those volcanoes in Hawaii, 14,000 feet, it'll be, 40 degrees at the top and breezy. Huge difference in temperature. And that's because, again, the temperature of the atmosphere drops 3 degrees Fahrenheit for every 1,000 feet in elevation rise. So elevation definitely affects climate and weather. So how does elevation affect climate? As the elevation increases, the average annual temperature decreases. As we go higher up the mountain, the temperature goes down. All right, another climate factor is called the orographic effect. This is another thing that we see in Hawaii quite commonly, in islands, but also in other areas, that if you have a ridge of mountains, and the wind, the global wind patterns are as here. So for example, if they're blowing from the west to the east, they are pulling in moist air. That moist, warm air rises, condenses into clouds as the air cools, because remember our elevation effect, as we go up, we get cooler air away from sea level, rains out. So we end up with a rainy windward slope. But now we've rained out. As we get on this side, that dry leeward slope, we have what's called a rain shadow, and we don't have any rain on the backside. So when you look at a map, you may see green on this wet side, the leeward side, or the windward side rather, and you may see brown leeward side on the opposite side where the wind comes from. All right, so for example, which one would be the windward side from the northeast here? The windward side here, the leeward side, brown, much less moisture. So this is not a temperature effect so much as a precipitation effect of climate. All right, how does the orographic effect affect climate? The windward side is upwards and rainy. the leeward side, the winds are downwards, and that is a dry side. How does elevation affect climate? Oh, that we already did that one. So another effect we see is the proximity to large bodies of water. So if you have a city that is on a large body of water, because of the heat capacity of water, you have water maintains its temperature more readily than land. So we're going to look at an experiment about that in a minute. But that the land, the soil, heats up faster and cools down faster than an equivalent amount of water. So notice in California, where you have the Central Valley, one of the places that really is kind of the breadbasket. We've lots of food for our country and the world is grown in the Central Valley of California. But look at the differences in temperature on a given day. By the ocean, proximal to a large body of water, the temperatures are in the 60s. If you go just 100 kilometers inland, you're away from that body of water and that high heat capacity of water, you end up in the 80s or 90s because that sun can really heat up that soil and then it will cool off fast again, whereas the water really has high heat capacity and holds the temperature pretty steady. So here's another example where you have Reykjavik, Iceland, which is by a large body of water, and you have another city, Yakutsk in Russia, where it is landlocked. And notice the difference in temperature. If we look at the months down here, January through December, that Reykjavik climate is really held to a more limited range of temperatures. And of course, these are in degrees C, not Fahrenheit like we're used to. But it's really held to a limited range of temperatures. Whereas in Yakutsk, Russia, you have a much hotter summers and colder winters because of that landlocked nature. All right, so how does closeness to a large body of water affect climate? Notice this graph, city A and city B. So which one is by the sea? And the answer, of course, would be city B because it is modulated. That body of water holds its heat, so it makes for a more mild summer and a more mild winter. Cooler summers and warmer winters. Whereas a city that is not by the sea is really going to be affected more broadly. Hotter summers, colder winters. So, locations near large bodies of water have cool summers and warm winters. Surrounded by land, that location would have a warm summer and a cool winter. All right, so again, these are the 6 factors that affect weather and climate. Ocean currents, air masses, latitude, elevation, orographic effect, and the proximity to large bodies of water. So you're going to do a couple of things now kind of on your own. And so, for example, you're going to say which climate factor explains the difference between Vail and Denver. And I'm going to show you, if you are in your slide deck here, you can move this up and down and it will allow you to see what's on the sides of your slide. Okay, so just move this right here and you can adjust how much you see. So if I go up like this, I can see those temperatures and you can zoom in and see what you need to see as far as the weather report for those areas. And you can notice, I want you to look at various data. You can see there's an elevation, quite a big difference between Vail and Denver. The latitude, so the latitude's about the same. The longitude would be this way. And what's the difference? And we notice that Vail, which is a much higher elevation, 8,000 versus 5,000 feet, Vail's a ski resort up in the mountains, and notice difference in temperature, is cooler. Well, what's the climate effect that's predominantly the difference between these two cities? Elevation, the elevation effect. So you would write it down here, the answer, elevation. So think about your different climate factors and which one applies to the cities that you see. And then again, you're also going to come here and think about, for example, which city, city A or city B, is closer to the equator. So the equator would be 0 degrees latitude. It's warmer. The sun is more direct. And we're going to look which one would be more near the equator. And I'm going to give you a hint to look at your scale over here, because these look the same, right? You look at them, they look the same, but the numbers are different. So this one, the top in July is about 80 degrees, whereas here in July, we're looking at north of 90 degrees. So this one's quite a bit warmer. So if I had to choose which one of these is closer to the equator, definitely city B. So you'll have a series of those thinking about answering those questions, think about your different climate factors. So you can go in and complete the rest of this assignment on your own. And I do want to walk through one more thing with you just to make sure you understand the heat capacity of water and soil. So if we did an experiment here, and I played this, you would see putting soil in a beaker, putting it on a heating element, and have water, what is happening, and notice the graph here as time passes. The soil is in red, the water is in blue, and I already talked about how water has a high heat capacity. So it is going to be harder to heat water than it is to heat soil. And notice the soil heats up faster than the water does as we look at this experiment. Now the next question is, all right, if we turn the heat off at the top, which one will cool down faster? Will the water cool down faster, or will it hold the heat that it does have, or will the soil or earth cool down faster? And we'll see as the experiment runs. Notice on the left-hand side, the temperature is being recorded at each stage. So I just speeded it up. Now we turn the lamp off and we let them cool down. Which one cools off faster? And notice the graph, that plummet, that soil plummets down faster. Water keeps it pretty steady. Comes down a little bit, but not as fast as the soil. So this is the reason why if you have a asphalt near the beach, if you're right next to the water's going to hold its heat. It's not going to get as hot and it's not going to get as cold as the temperature changes compared to the asphalt or an earthen surface. And this is why, because of this heat capacity experiment of soil and water. Okay, so I want you to make sure you understand that. And you can answer those questions in your lab as well. All right, thank you so much, and you are off to complete this and turn it in when you are done.